And welcome to today's debate on reworking advanced packages in PCBA, the risks, the reality, and the best practice. As advanced packages such as QFNs, BGAs, and CSPs and system and package devices become standard in modern electronics, rework is shifted from routine repair to high-risk process engineering. Here to debate these phenomena are my panelists today. We have Jörg Nolte from Kurz Ersa. Welcome, Jörg. And then Bob Morgensen from VJ Electronics. So welcome, Bob.
Good afternoon. Nice to meet you.
Okay. So I'm going to get straight into it. We're running a little bit late today, so my first question is going to be, what are the main technical risks when reworking advanced packages such as flip chips, BGAs, or FPGAs, and how can engineers accurately assess whether rework is feasible without compromising reliability? Now, the fact is, as we mentioned earlier, there's a lot of issues around these large BGA devices that are on, especially on these boards that are going into the data centers, and the issues of reworking these are quite considerable. So maybe you can kick off with that one, Jörg.
Yeah, sure. I mean, the risks, basically what we see in rework didn't change against smaller components when we look into these larger components. But basically, due to the size of these components, there are more factors you need to take into consideration. So, in example, the pure weight of these components, the pure size of the components, the warpage. This is topics that we have seen on smaller assemblies or smaller components as well. Yep. But in this particular case, it's going more to the extremes.
Absolutely. I mean, it is going to the extremes. So what are the methods that they should take to try and avoid the warpage? Should they double bake the substrates before they start? Should they? What sort of methodologies should they use?
I would say, unfortunately, you have not a general recipe for this. So there is still a lot of expertise required to really judge what's helping on the one or the other case. But it's like you said, the heat distribution, in example, over the entire package should be very small as possible. Yeah. So when you heat material in a homogeneous way, you may have less effects on warpage issues than when you heat it too fast with a too high gradient or with a too high delta T across the device. Yeah. So an example, when you try to keep the delta T from one corner of the component to the opposite corner below, let's say, 10 degrees Kelvin, you may have a good chance to achieve a good result in the end.
Right, okay. Bob, have you got anything to add to that?
Yeah, I'd add a couple things. I mean, first, one of the biggest issues we have with these large advanced packages is the cost of the package itself. Yep. These packages can cost upwards of $25,000, $30,000 each. So getting samples to work on and develop process is very difficult and costly in the first place. Yep. The other thing I'd like to talk about in the actual rework challenges is really what you need to have is a rework station that can emulate a reflow oven as accurately as possible and repeat what's going through the reflow oven. Mm-hmm. And that's something that we've worked on a lot, and we found, as you mentioned about the uniformity of heating, we found that the uniformity doesn't necessarily come from giving it the station giving it that uniformity. Sometimes you have to have multiple heat sources at different temperatures and settings to get the package itself, because it's made of different materials and is very large to heat uniformly.
Right. So getting the reflow profile is very
doing
critical.
The proper heating, having the heating very through the package, uniform in the package at the joint level, not necessarily from the machine level.
Right.
And the repeatability and basically of the machine is extremely important. Okay. From run to run, because these packages are so expensive. If your repeatability is different, you're going to have different results.
Different results, yeah. So you're with smaller pitches and more complex substrates, what are the current limitations of rework technologies, and where do we see gaps in capability that still force scrapping of the board?
Well, the limitations, I would say, are also on the board level size. So how large will finally the boards get? This is one topic you need to look at. Also, the board thickness is a topic, like you already said. The best would be to create the same situation like we have in a reflow oven or in some, let's say, a machine-operated process.
Yeah.
This is what we cannot achieve in all cases. I guess in your machine it's the same thing, because we are not in a closed environment, so we have to really take care how is the entire PCB behaving regarding the thickness of the material, the thermal capabilities. Are we really able to copy in a way the process that we've seen in the production, or to get even close to that? So these are really the thermal issues that we have to take care of.
Yeah.
Other than that, of course, we need to look at the handling of the component, board preparation, paste management, and the pick and place procedures. So you need to be able to handle the devices for picking and placing as well.
So Bob, does that mean like putting a higher number of thermocouples around the board so you can measure it more accurately?
Well, that's one of the things you can do, but I would say it's more on the side of looking at the component itself and seeing, getting some advanced sort of looking at how it's made, how it's on the board, what thermal challenge you have, and getting, on our systems, the tooling is sort of a key thing, and having the right engineering and making the right tooling to fit the component and heat it properly is huge. Going back to his talk, to the discussion of emulating a reflow oven, because we're working in an open air environment, we can't ever really quite get there, but we can, on the reflow areas, we can be almost exactly the same as an oven. It's more in the preheat and cool down at the end that the oven has an advantage over it. But there's been a lot of advances in technology on rework that have brought it closer, and I think as long as you go in with the attitude you're going to get a profile which is very close to a reflow oven but won't be quite the same because it's a different environment, I think you can work with that very well.
Right. Now you mentioned tooling there. I mean, I was up in a factory 2-3 weeks ago in the valley there, and they were showing me a 150 by 150 BGA, and they were using special tooling to put it through, where they were having to literally screw it down at each corner to keep it, to stop it from warping. What do you do to stop warpage at the rework level?
For us, it's a heat management, and we have 3 different heating systems hitting the component itself. 2 different large area preheater for heating the whole board, a localized bottom side spot heater to bring energy up through the bottom of the board to the component joints, and then a large area, a customized nozzle or tooling for the component to direct the hot airflow from the top side correctly on the component to distribute the heat well.
Right. Okay.
Maybe I can add here. Of course, the heating technology. So how you get the entire assembly and the component heated up is the key for that. I mean, pushing down the component by some clamps or whatever cannot be the final target. So every material that is put under pressure, there is tension, and if the tension is not released during the process, it will maybe release later on. So that means the solder joint will crack sooner or later. So you should avoid all this. The thermal management is the key. Here we have some differences in the machines, what you have and how we manage it. We were working without these tools for the specific component. We are having these open hybrid heaters from the top side and also infrared heating from the bottom side. But you can balance it out quite well. This is what our tests show. And as soon as we achieve this, the material is relaxed, and then we will achieve good results.
Okay.
On our side, we have a new machine with a new technology in it for the upper side heating, which is able to better balance the heat to the center of the component as opposed to the periphery. Because what
Is that
you
a hot
have
air
is
system?
on our system, because
Is it a hot air system?
yeah, it's a hot air system.
Yeah, okay.
So what we found is, especially on these 150 components, there's a lot of, they actually put stiffeners or actually metallic, metallized rim around the component,
Reinforcement,
which
yeah.
takes different heating. So we can actually have a new development for balancing that heating to the center and the edges to get it more uniform.
Interesting. Jörg, back to you. How effective are current post-rework inspection methods, as like X-ray, AOI, electrical testing, in verifying the integrity of advanced packages, and what innovations are on the horizon to improve confidence?
Well, actually, about the testing, this is of course not our core business, so we're concentrating on the rework process. But of course, during our evaluations that we're doing, we see that one key thing which is helping a lot in the last time in our evaluations was to actually see how the solder joint looks like. And as you know, still we are having our arsoscope in the program to see the solder spheres, especially on the corners and on the outline of the component. So how do the solder joints build up? How do they really look like? In addition to the information we receive from the X-ray. This is for us at the moment the key information to really see did we do a good job. And the afterwards testing on the electrical base is something where we are not really deeply involved, but for sure the complex components require more complex testing methods. And as you already mentioned in the beginning, Don, the prices of these devices are so high that it's just simply necessary to be sure that what you did is correct.
Right.
Otherwise, the money loss is really huge.
Yeah, I'd like to reinforce, we don't have much experience on the test side, but one thing that both our machines have that is an advantage over the assembly line is that we have these direct view cameras that can actually have high magnification, and because we're open air, we can look at the edges of look in the side of the component and actually see the BGA spheres as they go through the reflow process.
Right.
So you can confirm that your parts are on pad when they're placed, and you can look at the joints as they collapse and reform to see how they look before it goes on, and that's a big advantage to just get an initial view. Does it look good going
Absolutely.
out of the process?
Absolutely, I couldn't agree more. So, final question is, how do companies decide whether to rework or replace advanced packages, considering labor, equipment, and risk factors? And is there a consistent ROI strategy for high value or high mix production environments?
Well, we talked already about the money.
Yeah.
Every time you scrap a board or you scrap a component,
The cost.
it's a loss. On this particular component, it's a big money loss. So we see that other than in this specific AI section, more and more companies are deciding really to decide, let's go for rework, because the investment is relatively small. The processes, likewise on your machines and on our equipment, once they are established and installed, they are safe, they are repeatable. You can get the money saving in short time. So basically everybody in the industry is looking on that, because if it's the automotive, well, the automotive guys are still more critical towards rework, but we see this front is also opening. They are open for discussion. There is already the discussion what kind of components are repairable, whether it's small chip components, whether it's the regular BGAs or even others. This is coming more and more, and I'm very optimistic that this will be a trend towards the future. Yeah. A trend which is also, let's say, seeing a push over the complexity of all assemblies, what we see. No matter if it is industrial electronics, whether it's consumer electronics, medical, or like we discussed AI, the boards are getting more complex, they're getting more expensive, and so touch-up, repair, and replacement will pay back.
Yeah, well, you're absolutely right, Jorgen. I think you would agree with that, Don. As they get more expensive, it makes a lot of sense to rework them.
Yeah, I mean, the question is, you know, what's the value of the rework? You've got a 01005, which is not even worth value of 1 penny.
Right.
But if it doesn't work, the whole board doesn't work.
Right.
So, if you want to replace it and you want to replace it accurately and repeatably, do you want to do that by hand every time and risk destroying the whole board, or do you want to have a machine that's going to give you a good repeatable process that you can depend on every time, even though it'll take a significantly longer time to do than by hand?
You'll do it by hand, yeah, absolutely. Well, gentlemen, I think we've covered the topic reasonably well. I want to thank you very much for giving us your viewpoints on it. So thank you very much, Jorg. Thank you very much, Don. And thank you to our audience for tuning in today.
Thank you.